Okay, let's link quadratics now with functions. So you'll talk about functions quite extensively later on in the course. However, getting a good understanding, especially of these terms here in these yellow boxes, is very, very helpful. So if you're not familiar with function notation, functions just tell you how you get from your inputs to your outputs. So for example, -1 to 1, 0 to 0, this to this. The function that is x would do that. And so we say that there is a function of x. In other words, there is a situation where you do something to x, and the rule is given by x squared. This is pretty much the same at the moment as saying, y equals x squared. Domain refers to all of the inputs that you may have. And you're probably used to being able to use any input, but domain is often restricted, okay? For example, if we're looking at a sine graph, we might only look at some degrees. Or if we're dealing with a question with regular numbers, such as this, we might be told that you're only allowed to use certain values. So domain means all the values you can put in, the x values, in other words. Y values that can come out of a function, we call this the range. If you want to know what your range is, you can see that it would be quite important to know what your domain is. So, as we said there, often your domain will be that x belongs to the real numbers. You can take this to mean at the moment pretty much anything, as in x could be pretty much anything. The only exception, really, we can think of is complex numbers, but you won't do those unless that's further maths. We may also be interested to know what x values give us an output of 0. What x values give us an output of 0? Well, we know these as roots. That's when our function is equal to 0, for y equals 0. A worked example then. So let's have a look at this notation. So we have a rule of x. This is our rule. It's a quadratic rule. There is another rule of x. So these are different equations, different rules. And we have a restriction, but it's not very restrictive. We can use any real number. So find f of -2. Well, x has changed to -2. So that means you need to substitute in x equals -2. And you would write this then as -2 squared. X squared becomes -2 squared. -6, lots of -2, plus 2. And you'd put that all into your calculator. And I do have a calculator with me. Let me just do that one very, very quickly. So -2 being squared, take away 6, lots of -2, plus 2, I get 18. Okay, so when my input is -2, my output is 18. Notice I don't need to say y equals 18 now. Okay. Part B. What values are the rules equal to each other? So just as you would expect, we need to set these equal to each other. So x squared minus 6x plus 2 is equal to -2x plus 7. This is a quadratic. To solve quadratics generally, we move all the terms to the same side. So this will be x squared minus 4x minus 5 equals 0. And then you can use whichever method you prefer to solve this one here. I think this one factorizes quite nicely, so let's just do that. So -5 and 1. So when are these things equal to each other? Well, it's when x is -1 or 5. The roots. Well, the roots, this is just saying when x squared minus 6x plus 2 is equal to 0. Okay, so you could do something very, very similar there. If you haven't used it already, now is a good time again, perhaps, to check quadratic solver on your calculator. So if you turn this on, press menu, go to the section for A, press 2 for polynomial, 2 for the degree, and we can type this in. 1x squared minus 6 plus 2 equals 0. And it's telling me here, if I just double check I've typed it incorrectly, x squared minus 6x plus 2, I'm getting answers of x equals 3 plus or minus root 7. Okay, I'm just going to sort of jump ahead there because we've talked about the techniques to solve this already. The minimum point for g of x. Okay, so this is an interesting question because g of x is a straight line that goes through 7 and, whoops, I did not mean to do that there, has a gradient of minus 2. The minimum point of g of x, I'm just going to check because I think that should say f of x. So let's just verify that that question is correct. The minimum point of g of x. Yeah, okay, yeah, that one is a mistake there, okay? That one should say f of x. Because as you saw my straight line, if I have real numbers, there is no minimum. Whereas if I drew this quadratic, okay, 3 minus 7 would be the minimum point there. 3 minus 7 and 2. The quad, let's do that one again. 2 and 3 minus 7. The quadratic, apologies, my tablet's not the most responsive. One more time, 2 and then 3 minus 7. Okay, now it makes more sense. The question, it should be about f of x. Okay, completing the square and turning points then. So if we complete the square in this form here, well, imagine we're allowed to use any x values, okay? Imagine an x value of 10. 10 plus 2 is 12, 144, 149. That's a very large value. How small can you make this value? Well, you might want to try a negative number. Say you might want to try here minus 12. Minus 12 plus 2 is 10. 10 squared is 100. It's still very, very large. Why? Because it's being squared each time. So if you want to make this as small as possible, you need to try and make what's inside the bracket as small as possible. Well, that's going to happen when x equals minus 2. Minus 2 plus 2 is 0, and 0 squared is 0. You'd still have the 5, though. So if we play around, the smallest value that we can get is 5. When does it occur? Well, it occurs when we make sure that whatever's in the brackets adds up to 0. So minus 2 was the way to do that. Let's do another one. If we complete the square, we get this one here. Now, how can you make it as small as possible? Well, because this is being squared, this will always give you a positive answer. As small as possible is going to be when x is equal to 5, which will cancel that bit out, and you would get minus 4. When would you get minus 4? You get it when x is 5. So pause the video here, have a quick think about the other ones. So you need to complete the square first and do some thinking about the minimum or maximum values. So assuming you have done that, 10 minus x squared is sort of a trick question because it's already done. X appears once. 10. 10 is in fact the largest value. If you choose something else, such as x equals 1, you will get 9. All the other values, if you play around with them, will be less than 10. And finally, when x is 3, the bracket bit will be 0, so you'll be able to read off the 17. So this is helpful because we talked about roots from before, where things are equal to 0. We know the general shape from GCSE, whether it is sort of positive or negative. That helps us as well, by the way, determine if something is a minimum or a maximum. The y-intercept we could read off from the original equations. But now we are able to determine the turning point. So for example, with this one here, we know that the turning point would be at -2. Okay, that was the lowest that we could make it. This is not the same diagram, by the way. I'm just talking about the turning point. Okay, so this allows us to add maximum detail to our sketch. Sketches need to contain this information. They do not need to contain information such as this over here or this over here. They are not a scale diagram. So you should now be in a position to have a go at questions such as those from exercise 2E and F. And as a final test, check that you can use the techniques to sketch this graph on these axes. So pause the video here to have a go. The roots from factorization, the y-intercept can be read off from the original equation, and the turning point can be found by completing the square. Notice the connection. When you do the opposite of this thing here, which is this, the bracket is eliminated and it leaves you with what is outside here, which is the y aspect of the turning point.